Hello and welcome to chapter 4, which is one of my personal favorites. Has to do with trigonometry, and what would we would be remiss to not start with radians and degrees. What are they? How do we describe angles? How do we use radians? How do we use degrees? And then how do we use angles to solve problems? Okay, so let's start with angles. So what is trigonometry? Trigonometry comes from the Greek, which means measurement of triangles. And initially, trigonometry dealt with relationships among the sides and angles of triangles. And what is an angle? An angle is determined by rotating a ray about its endpoint. So let's say you have here, you have the vertex, right, the endpoint. You have a beginning side on the bottom, the initial side, and then it rotates up, and that's the end side or the terminal side. Notice that it's two rays and a vertex. Okie dokie. The endpoint of the ray is the vertex of the angle. So this concept of an angle fits a coordinate plane where the origin is the vertex and the initial side can be placed on top of the x-axis. If we do this, we can actually measure the degrees. So this angle, the way that it's put this way, where the initial side is on x and the terminal side is just somewhere on the coordinate plane, is called standard position. Okay, so here we have here the way that we measure the angle is counterclockwise. So we start with the initial side on the x-axis and we go counterclockwise for a positive angle, and then clockwise rotation generates negative angles. So if you have your starting place here on x and you go downward, that's a negative angle clockwise. So let's say here you have alpha and beta. So angles are usually labeled with the Greek letters like alpha, beta, theta, and uppercase letters A, B, C. Note that alpha and beta, like in this figure right here, notice that these have the same initial and terminal sides, but they're different angles depending on how you look at it. So let's say here, angle alpha, right, in the middle, the middle here, is positive, going counterclockwise from the x-axis, and beta is a negative angle going clockwise. Okay, even though they end up in the same place, they're coterminal, right? Coterminal, they end at the same place. So they have the same initial, same terminal side, but they are different measurements. Yeah. Okay, so notice this on the third set of axes here on the right. You have here an alpha, which is a short distance from the x-axis. So it's less than 90 degrees. But then if you go all the way around and then continue, that's still a large measurement, and it ends up in the same way, but you'll have two different angle measurements. So coterminal. All right, so let's talk about radians. What are they? So radians, you can determine the measure of an angle. Radians is a way to measure angles, okay? So let's think about this. So we can determine the measure of the angle by the amount of rotation from the initial side to the terminal side. So we're talking about how much rotation is there. So one way to do this is in radians, and this measurement is used so much in calculus. So to define a radian, we can use a central angle, or one whose vertex is at the center of the circle that we said, right? So let's say here you draw a circle, here's a radius, and then here's theta. So here is S, which is the arc length of the circle. Okay, so let's talk about what is the definition of a radian. A radian is a measure of the central angle theta that intercepts the arc S equal in length to the radius R. Okay, so what does that mean? That means if you take the ratio of the arc length that it intercepts, like if you put a circle on top and it cuts that little section of arc length, and you divide that by the radius, that's a radian. Okay, so if they're equal to each other, you would get 1 radian. Now let's think of a circle in general. What's the circumference of a circle? The circumference of a circle is 2 pi r. Okay, so all around, right? So a central angle of one full revolution corresponds to an arc length of s equals 2 pi r. Okay, so that means that s is basically like the circumference of the circle if you're just talking about the entire thing. So if 2 pi is approximately 6.28, that means that there's about 6 radius lengths in a full circle. Okay, so 2 pi is like one whole circle if r is 1, right? And so here, from here to here, it's 1 radian. From here to here, it's 2 radians. From here to here, it's 3 radians, okay? So it's about 6.28 radians. Okay, so now, because the measures for S and R are the same, their distances, the ratio has no units, it's actually a number. So let's think about this. So since one full revolution is S over R, which is 2 pi R over R, which is 2 pi radians, right? Half of that would be pi, right? Half of that would be pi radians. 1/4 of 2 pi would be pi over 2. And 1/6 of the entire circle would be pi over 3 radians. So let's look at that in a picture. Okay, so see here, pi would be this whole from the positive x-axis, and I took it all the way to the negative x-axis. In other words, 180 degrees, that's pi. Okay, so 1/6 of that would be pi over 6. Pi over 4 is 1/4 of that. See how they cut the top into 4 pieces. Pi over 3, they cut the top half into 3 pieces, right? Think of it as like you're cutting into a pie or a cake, you know. Pi over 2, 90 degrees, see the little box? Pi, that's just 180 degrees, right? Pi, half of the circle. And then the entire circle going from one rotation all the way around is considered 2 pi. The angle in radians is 2 pi. So remember from before, we know the 4 quadrants are numbered 1, 2, 3, and 4. So here, quadrant 1, which is from 0 to 90 degrees, you think of the angle measurement in radians goes from 0 to pi over 2. And an angle is in quadrant 2 if the degree measurement of the angle is from pi over 2 to pi, right? Quadrant 3, the angle would be measured from pi to 3 pi over 2. And then this fourth quadrant would be from 3 pi over 2 to 2 pi. Okay, so from angles between 0 and pi over 2 are acute, and angles between pi over 2 and pi are obtuse, right? Because they're greater than 90, less than 90. Okay, so two angles are coterminal when they have the same initial and terminal sides. They start in the same place, they end at the same place. But some might be going one direction and the others might be going another direction. So when you have the angles 0 and 2 pi are coterminal because they both talk about the positive x-axis, right? As are the angles pi over 6 and 13 pi over 6. We can find an angle that's coterminal to any other angle by either adding or subtracting 2 pi because you're doing like a revolution. Okay, so then any angle has infinitely many coterminal angles. So you would say something like, okay, pi over 6 is coterminal with pi over 6 plus 2n pi, where n is an integer. Okay, so let's consider positive angle 13 pi over 6, right? Subtract 2 pi to obtain a coterminal angle. So you just do 13 pi over 6. 13 pi over 6 is whoosh, one revolution and an So you're subtracting a revolution away, and then you just get pi over 6. So it's not too bad. Okay, what about this negative angle, negative 2 pi over 3, which went negative 2 pi over 3 in this direction clockwise. So let's add 2 pi to that, and what would we get? We would get 4 pi over 3, which makes sense. So two angles, alpha and beta, are complementary when their sum is pi over 2 or 90 degrees, okay? And two positive angles are supplementary when their sum is 180 degrees or pi. Okay, so this is in radians, we're talking pi is over 2. And so you should really familiarize yourself with like common radian and their degree equivalents, okay? So let's talk about degrees now. Second way to measure angles is in degrees. So that's denoted by the symbol degree, the little circle. Okay, a measure of 1 degree is equivalent to a rotation of 1/360th of a complete revolution about the vertex. So let's say, what does that mean? Okay, so that means going from like the positive x-axis, if I go all the way around, that's 360 degrees, right? So from 0, and I go all the way around, that's 360. So what does that mean? That 1 degree is it's just 1/360th, right? If I was to cut this all up into 360 pieces equivalent, then one of them would be equivalent to 1 degree. Okay, so what else was I going to say? Okay, so common angles, it's convenient to mark the degrees on the circumference of a circle. So let's say you have a circle here. This is theta. You can mark it. Like we know that the y-axis is 90. The other side is 180, the bottom is 270, and then coming back is 360. So between 90 and 0 is 45, yeah? Between 90 and 180 is 135, and so on. So notice the following, that 30 degrees is equal to 1/12 of 360, 45 degrees is equal to 1/8 of 360, and so on, okay? A full revolution corresponds to 360, a half revolution to 180, quarter to 90 degrees, and so on. 2 pi radians compares to 1 complete revolution. So you can say that 360 equals 2 pi radians, or pi radians is equal to 180 degrees. Okay, so that's really important that you remember that. So you can change this to look at 2 different equations. You have 1 degree is equal to pi over 180 radians, and 1 radian is equal to 180 degrees over pi. Yep. Let's see, any other thoughts on that? So basically you can say, you can use this to convert things. So let's go to convert from one to the other. So let's see what I mean. So if you want to go from degrees to radians, you start with degrees, you want to go to radians. You multiply the degrees by pi over 180, okay, because that will cancel out the degrees and give you radians. To convert from radians to degrees, multiply radians by 180 degrees over pi. So to apply both of these, we use the relationship pi radians is equal to 180. So see here, the pi over 6. So here it is, this figure here is kind of cool because it has both radians and degrees, so you can kind of see how they're related. Pi over 6 is equal to 30 degrees, pi over 4 is 45 degrees. These are the common ones. Pi over 3 is 60 degrees, pi over 2 is 90, pi is 180, and 2 pi is 360. So when you don't have, so now if there is no unit of angle measurement specified, it's implied that where you're going to assume that it's in radians. So they say theta is equal to 2. It's not like 2 degrees. We just assume that it's radians. Okay, so let's say here you want to start with 135 degrees and let's convert to radians. So I take 135 degrees, multiply by pi over 180, and then the degrees thing cancels, and I get pi radians. So 135 over 180 reduces to 3/4. So I get 3 pi over 4 radians. 540 degrees, multiply that by pi over 180, the degrees cancel, and you get 540 divided by 180, which is 3 pi. So you have the pi right here left over. Okay, so now some applications. You may or may not have homework problems on this, probably not, but I still want you to just at least be exposed to these concepts, okay, because we never know. So this radian measure formula, theta is equal to S over R, we can use that to measure arc length along a circle. So we multiply this by both sides by R, we can say that for a circle of radius r and a central angle theta, this central angle intercepts a piece of the circle So it gives us a arc of length s, and to find that actual length, we get r times theta, okay? So if r is equal to 1, if the radius is 1, then the arc length is equal to theta, and the radian measure of theta equals the arc length. So let's try something. So let's say here a circle has a radius of 4 inches. Find the length of the arc intercepted by a central angle of 240 degrees. So there you go. You see here's S, you have theta, you have R, right? The only thing is we need to use, we need theta in radians. Okay, because theta could be degrees or radians, but it's in degrees. So let's change it to radians. So let's go ahead and multiply by pi over 180. Simplify, okay, 240 is equal to 4 pi over 3 radians. Plug that into the equation, S is equal to R theta. So 4 times 4 pi over 3 gives us approximately 16.76 inches, okay? The units of R, which is inches, determine the units of the arc length, okay, because radians doesn't have any units. Okay, let's do another one. Some other formulas that you might see as you're walking down this path of math. So let's see here. We can also use this to analyze the motion of a particle moving at a constant speed. So a particle moving at a constant speed along an arc of radius r, if s is the length of arc traveled in time, the linear speed v of the particle is arc length over time, so s over t. Also, if theta is the angle in radians corresponding to arc length s, the angular speed omega is equal to theta over t. So that's something that we use with speed. Okay, and then finally, let's talk about sectors. What's a sector? It's, let's say you have this is a whole pie and you cut a chunk out of it, and the piece that you eat is a sector. Kind of makes the circle look like Pac-Man, right? So this pink part is the sector. It's the region bounded by 2 radii of the circle and their intercepted arc. Why is it called intercepted arc? Because it's intercepted between the 2 radians. The 2 radiuses. Okay, anyways, you can find the area of this sector by using the formula A is equal to 1/2 r squared theta, when you have theta in radians. So just in case, if you ever wanted to find the area of the slice of pie that you're eating, you can actually really calculate that. Okay, of course you'd have to maybe you could figure out the area, but then you'd have to multiply by how tall the slice is, so that you can actually get the amount of pie that you're going to eat, I guess. Anyways, dorky. So here's your super fun homework. 7 to 23 odd, and then 31 to 69 every other odd. And that's it for this section. I will see you in the next video.